So a student was driving the kinematics equations and was having a little bit of an issue. So I made a little video here just hoping that this will help. So let's look at our acceleration versus time graph. So we're talking about a situation where it's a constant acceleration. And so this is just a nice constant acceleration. And let's call the ending point to be time t. And so what we derive in the book is that then the change in velocity is the area under the acceleration graph. And I call this just acceleration A. All right, the area under that curve will be A times t. And so you can write it as velocity final equals velocity initial plus A times t. And that's one of our kinematics equations. All right, now the general form of the velocity equation is going to look like this here. And so let's do the same thing. Let's call the ending point to be time t. And now in general, there could be an initial velocity. Doesn't have to be 0, and I'll call this the final velocity. And so in the book calls displacement s, so the change in s will be the area under the velocity versus time curve. And so that has two pieces. So I think the person on Piazza, they were missing the second piece. So the first piece would just be 1/2, and if you look at this, technically it would be v final minus v initial times t. So that'd be the first piece. Then the second piece would be just v initial times t, just this area down here. So v initial times t. And then if I take this and rearrange it, what I want to do is I want to plug v final in over here for v final. So it'll be 1/2. My v final will be v initial plus at, but then there's minus the v initial here from this guy over here. And so that's times t, and over here plus v initial times t. Now inside here what happens is the vi's cancel, and I get a times t times 1/2. So I get 1/2 at squared plus vit. And this, of course, is the equation that we're looking for. So I think that's where the mistake was made.